Okay, continuing on from the previous video, in the next couple minutes I want to discuss the changes in various physical states and what those are called. Like I said, essentially you can have only three types of physical states. Well, for the purpose of this class, we have either solids, we have liquids, or we have gases. These are my three solid states. And the best one to consider actually to understand all three of these is to use water, because we know water, how it exists. Water is a solid in the form of ice below 0 degrees Celsius. It's a liquid between 0 and 100, and above 100 it is a gas. So it's the easiest to understand. That's what we will go with. But realize in terms of process, if ice is allowed to just stay at room temperature, what do you expect? Obviously it's going to melt, and that process will be called as melting. On the other hand, if you take water and you put it in an ice tray or something and you put it in your freezer, which is below 0 degrees Celsius, what happens? It goes through a freezing process. That means the liquid gets converted into a solid, and that's what we call a freezing process. Realize that the temperature at which this melting takes place, or the temperature at which the freezing takes place, is exactly the same. For the case of water, it happens to be 0 degrees Celsius. 0 degree Celsius. And we like to call that 32 Fahrenheit. In the United States, but the rest of the world uses the Celsius, which earlier at one point of time was also called a centigrade. And the scientific world would have a Kelvin scale, but I'll discuss these scales a little bit later today in another video. In addition, you can perhaps think about vaporization. For instance, vaporization is a process in which a liquid gets converted to a gas. If you want to think about it, let's say you want to get started and develop, generate for yourself, make for yourself some tea, or maybe you want to boil eggs, whatever. You are boiling water. So what happens? The liquid water, it gains sufficient energy and it rises up and essentially gets converted into water in the vapor form. And now if you put a lid on top of it, what's going to happen is that that water will rise up and it will condense against the lid, and then it will drop back down. And so what I'm saying here is that you have this beaker. In this case I'm showing you bromine. If you put a lid on top of it, then the liquid bromine is going to condense against the walls and against the lid, and it's going to just condense back down. So please realize that vaporization and condensation, these two are again processes that occur exactly at that same temperature, and so these are essentially, the forward reaction is called vaporization, the backward reaction will be called condensation. Now the third set will be sublimation and deposition, and a classical example of this would be if solid gets converted into a gaseous form. The best example will be considering mothballs. Hopefully everybody knows, and if you don't, then the next time you go to the grocery store, maybe Walmart, go to the laundry section and look for these this blue box from Great Value, and it has these little white spheres like that, and they are called mothballs. M-O-T-H, mothballs. And they contain an organic compound called as naphthalene, which looks like this. I'm going to try to draw it as well as I can. Just because this mouse is okay, 2 6-membered rings. Those of you who have to take organic 1 and organic 2 will learn a little bit more about naphthalene, but essentially this naphthalene is a planar compound. It's flat. So when insects essentially lick on it, or since it sublimes essentially when insects get it into their system, this intercalates in between the nitrogen bases of the DNA and basically kills them. And so mothballs, these sublime after a while. You won't even have a trace of that, and the reason for that is because the solid gets converted into the gas format, and it does so without going through the liquid phase. The opposite of that, which is frost formation, is the conversion of gas into the solid format, and that will be called as deposition. Again, the temperature at which this occurs is exactly the same. So solid to liquid called melting, liquid to solid called freezing, liquid to gas called vaporization, gas to liquid called condensation. Going from solid to gas, that will be sublimation. Gas to solid, that's deposition. So one can hopefully say that if you're increasing the temperature, you can go from solid ice to gaseous water vapor. If we are set with that, let's go forward and go ahead and understand the classification of material particles. So matter can be classified into two categories. One is mixture, the other is pure substances. Within the mixture, we have two kinds. One is called as homogeneous mixtures. Let's write that somewhere. Homogeneous mixtures, and the other is called as heterogeneous mixtures. The one thing that I want you to realize for mixtures is that it contains more than one substance, and these can be physically separated. What I mean by that is that if you have, let's say, a mixture of iron and sulfur, okay, and you can take a magnet and just move it on top of this iron and the iron and sulfur mixture, and the magnet will be able to remove the iron particles, and so you are able to separate out the various the two components from each other. Pure substances, on the other hand, are composed of only one substance. They cannot actually be physically separated from one form to another. There is no other form, essentially. It contains only one substance. It cannot be physically separated. What that means is, let's say you're thinking about a gold ring or a copper wire, and you start breaking down this gold ring or copper wire into as tiny particles as you can. Realize that the copper wire still remains copper wire, the gold still remains gold, until you reach a point where you have just one atom of copper or one atom of gold. And so a pure substance essentially is it contains only one substance that cannot be physically separated. If you want to break it down into other things, such as a pure substance which is a compound, you will need some kind of chemical means. You will have to carry out some kind of a chemical reaction to be able to get it to go that route. But otherwise, you cannot really break down pure substances into smaller particles. Okay, coming back to mixtures, like I said, two kinds, homogeneous and heterogeneous. Homogeneous mixtures are those which have uniform properties, whereas heterogeneous mixtures are those which do not have uniform properties. And so classical example would be if you contain, let's say, salt water. If you consider salt water, or you consider vinegar. Vinegar is acetic acid and water. Salt water, of course, we know, seawater. These are homogeneous. You can never tell which part is rich in water, which part is rich in salt. It's just one uniform component. And even though there are two things in there, you will consider this a mixture because chemically they are different. Now, you can take salt water and you can just subject that to boiling or distillation, which is a physical method, and that will separate out the water from the salt. So you can actually take a homogeneous mixture and separate the two components out. Now, if you consider something like sand and water, in case of sand and water, there is a region that contains sand and a region that contains water. So if you allow it to settle down, the sand basically settles at the bottom, and you can simply filter it or decant it to be able to separate the sand from the water. And this will be called as a heterogeneous mixture, because in this case we are able to actually see the region that is rich in sand and the region that is rich in water. So we call this a heterogeneous mixture. Like I said, there are two kinds of pure substances. One is called as an element, the other is called as a compound. So an element, well, when you try to break it down further, essentially, you can't get anything other than itself. Whereas when you have a compound, you will need to have some kind of a chemical reaction, but you will be able to decompose it into its corresponding elements. So for example, if you have, let's say, water. Okay, water. Oh, what happened here? H2O. Now, water can be broken. It can be broken into hydrogen gas and oxygen gas, H2 and O2. So we will have to put in 2H2, just to balance it. And this will occur only if you carry out a process called as electrolysis. So this is not something that you can carry out in your garage or in your kitchen. You need specialized equipment for this to be able to decompose water into hydrogen gas and oxygen gas. And so pure substances like pure water can be chemically separated into individual components. On the other hand, if you consider an element, anything on the periodic table, that is an element. Gold ring, so gold is an element, silver is an element, copper is an element, such oxygen that you breathe, nitrogen, all of those are elements as well. All right. So this is to just kind of summarize what I have been saying in the last couple minutes. Matter can be a mixture or be a pure substance. If you think that it is separable by physical means, you'll call it a mixture. If not, you'll call it a pure substance. If it's uniform, that would mean it's a homogeneous mixture, such as air. On the other hand, if it's heterogeneous, such as salad dressing, you're going to say that it is a heterogeneous mixture, where it will be non-uniform. And pure substances, if they are decomposed by a chemical process, you're going to say that it's a compound. If not, you're going to say it is an element. Okay. All right, let's talk about properties of matter. Now, properties can be of two kinds. There are two ways to actually distinguish between them. One is called as intensive property, the other is called as extensive property. When a property depends on the amount that you have taken, for example, length, volume, kilograms, it depends on the mass that you have taken. Essentially, you use the word extensive property. And if you have intensive property, that would mean that it does not depend on the amount. For example, if you take a cup of water and if you take a bucket of water or a swimming pool of water, you're increasing the mass each time. But if you're thinking about the melting point or freezing point, water is water. Water is going to freeze at 32 Fahrenheit, 0 degrees Celsius, or it will boil at 212 and 100 degrees Celsius. So this property is independent of the amount that you have taken, and hence we use the word intensive for that, and this kind of property will be called as an intensive property. Now, another way to distinguish between properties is physical and chemical. Let's write that somewhere. Physical and chemical properties. You can consider a chemical property as if it's a chemical reaction. A physical property is something which is going to be determined without changing the chemical makeup, the chemical nature of a certain given sample. So things like melting point, boiling point, phase changes, going from solid to liquid, liquid to gas, that kind of thing. That is going to be an example of a physical property. Colors is again a physical property. Whereas oxidation will be considered as a chemical property. I'm going to get into more detail in the next video.